Okay, we just talked about video transmitters. Let's talk about the all-important things that sit on top of them, antennas. Okay, this is called an omnidirectional antenna. Just like on my transmitter, I've got an omnidirectional. Means it transmits omni, which means all around. The gain comes out like in lobes. If I sliced up an apple, that's what the or a donut, that's what the lobes look like, with not much gain coming out the top of the lobe. Okay, here's my antenna. The gain looks like that coming out. So coming directly perpendicular out is the most gain. That'll go at a certain distance depending on my output power, and the gain drops off. So at the top you can see there's very little gain. That's why they provide these elbows in, so that you can point it. That's my aircraft flying here, my drone. I point it that way at the drone. That is not good. That's minimal gain. Trouble is, if I've got this particular, I need this on my transmitter, this is on my aircraft, and I've got a similar one on the ground. I can point the one on my ground in my aircraft as it flies around, like flying like that. But on my aircraft, it's constantly banking. Okay, so most gain is out the side, like I said, but as the aircraft banks, it might start pointing towards my ground station, and my gain is reduced. My video quality might be reduced, or signal reduced. Which, with these omnidirectionals, they're cheap. They're also called rubber duckies, by the way. Rubber ducky antennas, omnidirectional. I can't remember what I was going to say, but it doesn't matter. To overcome that problem of this rotating as it turns, some bright spark bored out a high gain antenna. Correction, not a high gain antenna, a Cloverleaf. Now you'll see on some of the drones on the board here, in here are some lobes that are shaped like Cloverleaf. What that is, I can't get into it here. What that is the aircraft turns, there's always one of the lobes pointing at my ground control station. Okay, so they look like a cloverleaf like that. It's on an angle, covering all particular angles that the aircraft will be banking at. Receiver, that should be on my ground station. It's not going to make a terrible lot of difference. This happens to be on this transmitter. This connector here is called SMA. Just make sure this one's got a pin in there. Make sure that they're male and female, that they match up. If there wasn't a pin in there, no pin in there, then it's not going to work very well. Because this is active, it's transmitting, there's power coming in, always have an antenna on here, or else it's pumping this energy into nothing, and it's going to back up and burn out something in here. So have your antenna on all the time, so that you can dissipate that energy. Same with a dipole. That's the word I was looking for on this Omni. It's dipole antenna. Okay, so that's the antennas. You can get high gain antennas, such as a satellite dish or a patch antenna, which points to a certain area, like a dish does, and so the gain goes out there in a cone, like a funnel. So the aircraft flies within that funnel. You can actually have this on your ground station. You can actually project further passively. It's like a hearing aid that's projecting outwards. But if you fly outside of that cone, you'll lose gain. Around the back of the ground station, you'll get nothing. So if you're flying at long distances, you'll have some kind of patch antenna or dish antenna that can project its listening pattern out wide. Its gain is that way. Compared to an Omni, looking straight down on top, the gain is circular. You can fly around. Good for close in, probably all you need for the UAV challenge. Have that on your aircraft, a matching one of those on the ground. If you've got that on your aircraft, if that's all you can afford, have a matching dipole on the ground. Don't mix and match antennas like that. Antennas.